All right, I think that's probably good for word problems. Let's go into this topic a little bit. It's called the complementary angle theorem, and it's one of the simplest theorems you'll ever see. Co-functions of complementary angles are equal. But what does that mean? Well, first let's start with this word, co-functions. Sine and cosine are co-functions. Tangent, and can you think of another word or another trig function that starts with co and ends with tan? Co. Oops, why did I write cosine like that? Sorry about that. And cotangent are co-functions. And believe it or not, secant and cosecant are co-functions. So now we know what co-functions are. Sine and cosine, tangent and cotangent, secant and cosecant are co-functions. Cool story. I'd like to put most of our thoughts, our look, everything into sine and cosine. I'm going to give you a full thing. But let's just think sine and cosine for right now. All right, you can figure that out. Sine and cosine are co-functions. But now let's talk about what does complementary mean. And we should already know that, right? So if you have an angle phi and an angle theta, well, if you add the two of them, if they're complementary, they're 90 degrees. Just adding them two things up. Sorry for writing so much Greek, but I want you to start getting used to some Greek. So it says co-functions of complementary angles are equal. Can I just do some random old numbers here? They're totally not random. How about 30 degrees plus 60 degrees? That equals 90, right? Those are complementary angles. So what this is saying is, let's take sine and let's just pop in 30. And then let's use this co-function, cosine, and take the other angle, the complement of the angle. Well, what's sine of 30 equal? 1/2. What's cosine of 60 equal? 1/2. Oh. Co-functions of complementary angles are equal. Well, let's see it another way. Maybe that way doesn't work well for you. Got something going on. So let's just look at, I want to see what's sine of A. What's sine of A? That's going to be our opposite over our hypotenuse. That's just A over C. Okay, well, let's talk about its co-function. So the co-function to sine is cosine. Now, what's the angle? What's the complement of A? It's B. So what's cosine of B? Now we're looking from here. I just lost my A. We're looking from here. And we go, well, from here, cosine's the adjacent it's the same thing. Co-functions of complementary angles are equal. We can play the same game with tangent of A. Tangent of A would be our opposite over our adjacent. And if we go with cotangent of B, it would be our adjacent over our opposite. And they're the same thing again. That's the complementary angle theorem. Well, here's a big long-winded thing there with what I just said, saying that the co-functions of complementary angles are equal. Cool. Let me ask you a question. If sine is equal to 41 degrees, or sine is not equal to 41 degrees. You plug angles into trig functions. So if I say sine of 41 is equal to cosine of what? Well, sine and cosine are co-functions. What would it be? Co-functions of what are equal? Complementary angles. So we'd subtract out the 41 to get an answer, and we find out that cosine of 49 degrees is equal to sine of 41. I like putting those on tests. Real simple. Just as it sat before. Bang. What's it equal? That's no big deal. So let's just try one more and then we'll be done. This time I'm going to say cosine of pi over 5 is equal to sine of what? This used to be on all of my first exams. This problem would be the most successful problem in the whole thing. And this would be the least successful because there's fractions. So if we're talking complementary angles, I had up here before 90 minus 41. Well, now we're in radians, so we do pi over 2 minus pi over 5. Can you subtract two fractions? Can you do 1/2 minus 1/5? I'm sure you can. Oh, I'm sorry. Did I say 1/2 minus 1/5? Yeah, it's the same exact freaking thing, except there's going to be a pi in your answer. So let's just do this off to the side, and let's be done with this section after that. You need common denominators. Since the right one has a 5 in the bottom, I'm going to give the top a 5. Well, since the bottom one has a 2 on the left, I just want to keep it consistent. There we go. We have a common denominator. So it's 10 in the bottom, 5 times 2. So we have 5 pi minus 2 pi. 5 of a thingy minus 2 of a thingy is 3 of a thingy. So the answer would have been 3 pi over 10. I'm not sure whether you'll see this on an exam, but you could. You could. So this little table here is just showing what we had done above. But I showed you the way that I like to ask these questions if you are tested. So that would be the game. But I've used this just to show you that all this is true. So that's the complementary angle theorem. All right, that's it. Next video, you'll be moving into my older videos that I made back in spring of 2020, which are going to cover your 4.2, 4.3, and 4.4, except your 4.4 is going to be mixed into your 4.2 and 4.3 because it's from an older textbook. 4.2 is the law of sines. 4.3 is the law of cosines. And 4.4 are area problems. But they're all mixed in with the area problems are all mixed in with my 4.2 and 4.3 videos. So you're going to get all of it in one shot. So, okay. Guess I'll see you there.